Hello, welcome back. Today we're going to be solving quadratic equations by graphing. The objective is that by the end of this video you should be able to do two things. Find the zeros of a function using your graphing calculator and solve an equation that looks like this. To get us started on our first objective, we got a couple of definitions. The first of which is a zero of a function. A zero of a function is the value or values of the independent variable to make the equation equal to 0. For example, m equals to 2. The value of m, if m is 2, it's a zero of this function right here. Because when we take 2 and we substitute it in for m on the right hand side of our equation, it makes the right hand side of the equation equal to 0. So taking a look at that, is b equal to 3 a zero of h of b equals b squared plus b minus 12? Well, to check that, we're going to substitute 3 in for the b. Note again that this symbol right here, h of b and h of 3, we don't do anything with that. We just leave it h of 3 and it stays just like that. That says the value of h when b is 3. So we're trying to find out what h is when b is 3. Well, to do that, we put 3 in for all the b's, 3 squared plus 3 minus 12. So h of 3 is going to be equal to 3 squared is 9 plus 3 minus 12. 9 plus 3 is 12 minus 12, which is 0. So is b equal to 3 a zero of our function? And the answer is yes, because it made the function equal to 0. So go ahead on your own, try to see if c equals negative 6 is a zero of f of c equals 3c squared minus 4c plus 2. Pause the video, press play when you're ready to see the answer. So I went ahead and substitute negative 6 in for our c values. And I got f of negative 6 is equal to 108 plus 24 plus 2. And I didn't even bother adding that up because I know it's obviously not 0. And all I was asked to do is find if c equals negative 6 is a 0. In other words, does it make our function equal to 0? And no, it equals some number much bigger than 0. So all you got to do is say no. On a graph, our zeros show up as the x values that make the y values equal to 0. So taking a look at our graph right here, can I quickly identify two zeros? Right here at negative 1 and right here at 3. So the zeros of this function are x equal negative 1 and x equal to 3. So what we're going to do is we're going to find the zeros of a function using the graph on our graphing calculator, and here are the steps we're going to go through in order to find those zeros. I'm going to have you write them down first so that you have them to reference while we talk about them and work through 3 examples of finding zeros on a calculator together. The words are, we're going to put the function into the y1 equals, put 0 into y2 equals, because we're going to try to find out where the function equals 0. Then we're going to go to our second trace intersection, and we're going to find out where y1 and y2 meet. We're going to hold down the left or right arrow key until we get close to the intersection we're trying to find. In other words, where it crosses the x-axis, the zeros, and then we're going to press enter 3 times. So I've got 3 examples here. We're going to work through these 3 examples. I'm going to do the first one, then have you do the second 2. And we're going to find the zeros of each one of these functions. Now, first thing, we go to y equals, and I know it does not say y equals on our function. What I want to let you know is that when it comes to the graphing calculator, you can call h of w, this whole big thing on the left-hand side, you can just call that y. And this should be a w right here. And what we're going to do is we're just going to change our variable. Instead of calling it w, we're just going to say x. Because your calculator will not graph a w, it's just going to graph x. It's okay. In our final answer, we're going to write w equal instead of x equal. It's just to get it in our calculator, we have to write x instead of w. Sort of like on the last example here, you're going to write x instead of b. Alright, so we go to our calculator, we go to y1, and we're going to type in x squared minus 2x minus 8. And let me point out that we're using the subtraction button right here, not the negative button. The negative means we're like adding a negative number, multiplying by a negative number. We're not. we're just subtracting 8 and subtracting the 2x, so we use the minus button. Now press enter, and your y2 you're going to put 0. I'm going to go to my graph, and before I go to the second trace, and you'll notice that our little parabola right here crosses the x-axis or has a y value of 0 in two different places, and our goal is to find out those two intersections. So to do that, I'm going to go second, trace, go down to intersection, press enter, and you notice my cursor is blinking right here. I'm going to hold down the left arrow key until I get close to the intersection I'm trying to find. I'm trying to find out where it intersects y equals 0, or where it hits the x-axis right here. And I'm fairly close, so what I'm going to do is I'm going to press enter, enter, and enter again. And you get your first intersection. X is equal to -2. Now again, we don't want to use x, we're going to use w, so we write w equal to -2. So that was one of our zeros. You'll notice it crosses over here too, so what we need to do is we need to use the exact same process to find that other zero. So we go second, trace, we're going to go down to intersection, and we're going to hold our right arrow key, in this case, because I got to go to the right, until I get close to that other intersection, that other zero we're trying to find. And I press enter 1, 2, 3 times. Once it says the word intersection, 4 and 0, I know I have my answer. My answer is just the x value that makes y equal to 0. So my other zero is w equal to 4. Remember, we're using w instead of x for our answers. Now those are the zeros for this function right here. See if you can find the zeros for the next two functions following the example that we just got through using. Press pause, work them out, and press play when you're ready to see the answer. So I went back to my y equals, I pressed clear, and I left 0 in for y2 since I'm going to use 0 again here in a second. And I go 4x squared minus 12x and then plus 9. And I go to my graph, and I notice in this case, you know, it looks like it just hits once on that x-axis, and that's kind of hard to see. So what I'm going to do, you don't have to do this, it just makes me feel better knowing whether or not it's going to cross that x-axis twice. I'm going to go zoom, and I'm going to go down to zoom box, and I'm going to press my arrow key, and what this is going to do, it's going to set a box, and right here I've got my box started. I press enter. That's going to become the upper left hand corner of my box. I'm going to hold over my right arrow key and then my down arrow key, and you see it creates a new little window. When I press enter, we're going to zoom in on that little window right there by using the zoom box command. Press enter. And looking at it closer up, we notice, hey, it looks like it just intersects that x-axis or has a value of 0 just once. So we're going to go second trace, down to intersection. I'm just about on top of that intersection, so press enter, and press enter again. And our 0 is x is equal to 1.5 for that second function. So I write x is equal to 1.5. For that third one, now third one's a little tricky. Again, we go to y equals, we press clear, and we go negative x squared plus 6x minus 10, and we go graph. Now you'll notice my graph's still zoomed in, so it's not a really good graph to see. Anytime you want to go back to your standard window, you go zoom, and you go down to standard and press enter. That gets me back into a 10 by 10 viewing window. Now looking at our parabola right here, we notice that our parabola never crosses the x-axis, which means our function value, r of b, will never reach 0. So it's kind of hard to find the intersection when it never actually crosses. So in this case, we say that there are going to be no real zeros. Now there's something called an imaginary zero. We're not going to mess with that right now. That'll show up in Algebra 2. We're now on to our second objective, which is to solve an equation like 3x squared minus 5x equal to 12, and we're going to solve that using our graphing calculator. Now, vocabulary to solve an equation means that we find the solution or solutions to the equation. Second vocabulary word, a solution to an equation is one or more numbers that can be substituted in for the variable or variables in the equation. That'll make the equation true. Example is -2, a solution to the equation x squared equal to 4. To find out, we would just substitute -2 in for x, giving us -2 squared equal to 4. -2 squared is 4. So when we work that out, let me write an arrow key over here. We get 4 equal to 4, which does indeed check out. So yes, -2 is a solution to our equation because it makes the left-hand side equal to the right-hand side. So all this brings us to our second objective, which is to find the solutions of an equation in your graphing calculator. We're going to go kind of through a tricky process to get there. When I say tricky, what I mean is it helps us bypass a whole bunch of work. What we're going to do is we're going to make the equation equal to 0, and since we made the equation equal to 0, all we have to do are find our zeros to the function. And third step's always a good idea, to check our solution. So I've got an example right here. And again, what we're going to do first is we're going to take that equation and we're going to make it equal to 0. So to do that, I'm going to subtract 10x from both sides, giving us 2x squared minus 6x minus 10x is -16x plus 2 equal to 0. So this is our function, and what we're going to do is we're going to type that into our calculator. So we get 2x squared minus 16x plus 2, and we put 0 in for our y2. So that's going to allow us to find out where this equation is equal to 0. And we go ahead and graph. Now you'll notice that we can't quite see everything on our graph, and in this case that's okay, because all we're looking for is where the graph or the parabola, since it's an x squared function, crosses the x-axis. Since it's x squared, it's going to cross, in this case, twice. And what we're going to do is we're going to go second trace, go down to intersect, press enter. Now notice my cursor is blinking right here. I want to be blinking as close as possible to that first intersection. That gets me fairly close, and I press enter 3 times. So our first solution ought to be 0.127. I'm going to round to 3 decimal places. So x is equal to 0.127. Let's go ahead and find our second one. To do that, we use the same process, second trace, go down to intersection, press enter, and you hold the right arrow key. It's going to go off the screen for a second, that's okay. And we're just going to hold it down until eventually, there we go, we get close to the intersection, press enter 3 times, and you get the second solution is 7.873. So 7.873. And there you go, you found your 2 solutions. Again, it's always a good idea to check, and you can check by substituting those values in for x using your graphing calculator. Now, since we rounded, you're going to make sure the left-hand side is really close to the right-hand side. I'm not going to show you how to do that right now. Really wanted to focus a lot on how to find the solutions, and I'm going to have a couple more examples for you to work here in a second. Here are 3 more examples for you to try on your own. Go ahead and press pause, work them out, and press play when you're ready to see the answer. So I went ahead and solved each of the 3 equations for 0, got each equation equal to 0 rather, and I'm going to start with that first one, -x squared minus 8x minus 16. And I do just like I did when I found the zeros. I type it in, -x squared minus 8x minus 16, and I graph. Notice it crosses only once, looks like, so I go second trace intersection. And I don't really see my curve because right now x is at -1.27, so I keep on holding it down until I get to almost the intersection. Press enter 3 times. And I find my value to be -3.99999, which rounds to -4. So the solution for this one is x equals -4. Alright, for the second one, we go ahead and type that in. We get 4x squared minus 3x minus 5. We graph it. Notice it crosses twice. We got to find two intersections. Second trace, intersection. Press the left arrow key till we get close. I'm going to press enter 3 times. And one solution is x equals negative 8.04. And we still have to find the other solution. So we do the same process, second trace, intersect, and we scroll over till we get to the right, press enter 3 times, and we get x is equal to 1.554. So we've got our two solutions for this one, and as you might be able to guess, for the third one, I wanted to give you an example where you had no solution. So negative 3x squared plus 6x and then minus 5, and you graph. Notice the graph never actually crosses the x-axis. So for that last one, we say that there is no real solution.